Welcome geometry students to week 4 of distance learning. This week we are advancing into volumes. So the two lessons for today are going to be volume of prisms and cylinders and then pyramids and cones. I went ahead and put up all of the important formulas on the whiteboard. The volume for a prism is the area of the base times the height. So for any prism that you have, the area of the base times the height. For a cylinder, the volume formula is the exact same, the area of the base times the height. Now for a cylinder, that will always be pi r squared times the height, because the base is a circle. For pyramids and cones, all you're going to see different from the prisms and cylinders to the pyramids and cones is that you're going to take the volume and multiply it by 1/3. So the volume of a pyramid is 1/3 the area of the base times the height. And for a cone, same thing, 1/3 the area of the base times the height. And for a cone, that will always be pi r squared times the height. Now I'm going to give you a second to write those down, and then we're going to look at 4 examples for these lessons. We're going to look at 2 examples dealing with prisms and cylinders, and then we're going to look at 2 examples dealing with pyramids and cones. Example 1, we're going to be finding the volume of this triangular prism. The volume is the area of the base times the height. Because this is a triangular prism, we are going to be finding the area of the base, or that triangle, times the height. Based on what is given to us, we already have the height. The height of this prism is 10 inches. What we need to go in and find is the area of the base. Now in a lot of these questions, you're going to have basically all the information you need to plug into the formula for the area of the base. But in this example, I wanted to show you kind of how it would look if you weren't given exactly the information you need to find that area. So in this case, we are given this base triangle that has lengths of 12 inches and 15 inches, which is great, except for we know the area of a triangle is 1/2 base times height. So 1/2 base times height. The base in this case is 12 inches, but we do not know the height. So since we do not know what the height is of this triangle, we're going to have to go in and use our Pythagorean theorem to find that height. So a squared plus 12 squared equals 15 squared. So a squared plus 144 equals 225. A squared equals 81. So in this case, we'll square root both sides, and A is 9 inches. So we go to our formula, put in 9, and calculate. So for the first example, our answer is 540 inches cubed. With volume, you're always going to have the units cubed, because in every single one of your formulas, you're going to have the area of the base, or the squared units, times another one of those units. So we had inches times inches times inches. So inches cubed. Example 2. This is called an oblique cylinder. The reason why it's called an oblique cylinder is because it's leaning. Now there is a principle called Cavalari's principle that states even for oblique figures like this, the same volume will apply. So in this case, the area of the base times the height. The only difference is when you see an oblique figure like this, you have to make sure that you have the actual height, not the length from the middle of the top to the middle of the bottom. That's not the height of this figure. The height is the altitude for this oblique shape. Now let's use our cylinder formula to find the volume of this oblique cylinder. To find the volume of the cylinder, it is pi r squared times the height. The height is 10 meters. The radius is half of this diameter, so 2 meters. And then we'll calculate. So pi 2 squared times 10. So for this example, the volume for this oblique cylinder is either 40 pi meters cubed or 125.7 meters cubed. So in this case, you could have left it in terms of pi, so 40 pi, or you could have used 3.14 or your pi button to come up with an approximation here. Either answer would be accepted. Okay, for example 3 and 4, we're going to be looking at pyramids and cones. For example 3, we're given a pentagonal pyramid. In example 4, we're given a cone. For example 3, you are going to be using the 1/3 area of the base times the height. I wanted to look at one of our regular figures, so a pentagonal pyramid here, just so we have to go in and use our formula 1/2 AP, apothem times the perimeter, for this example. Now luckily for us, they gave us every piece of information that we really need. They gave us the side lengths of each of the sides, which is 4.4 meters. They gave us the apothem, which is 3 meters, and they gave us the height of this figure, which is 12 meters. So the volume for this pyramid is 1/3 times the area of the base, which is the area of that pentagon, which is 1/2 AP. So in this case, 1/2. Our apothem is 3 and our perimeter is 22. Times your height of this pyramid, which is 12. When you plug this in, you get 132 meters cubed. Example 4, the cone. For this example, I wanted you to see how it would look if you were given something that you had to use, say, your sine, cosine, or tangent. So we're going to look at this cone question that has a radius of 8 meters and the degree at the top between the side of the cone and the middle, or altitude or height of the cone, is 20 degrees. With every cone question, you're going to use the formula. One-third the area of the base times the height, or one-third pi r squared times the height. Now in this example, we are given one of the two pieces of information that you need. One-third pi 8 squared times h. We still don't have h. H is that height of the figure. So in this case, we're going to have to find h, and to do that, we're going to have to utilize our sine, cosine, and tangent. So we have 20 degrees, 8, and h. We are given the opposite and the adjacent, so we're going to be utilizing tangent of 20 degrees equals the opposite over the adjacent. And we're going to solve for h. Multiply h to the other side. Divide the tangent of 20. And 8 divided by the tangent of 20 will be our height that we will have here, and we'll plug into the volume formula, which, when rounded, is 22. And then when you calculate that, you will get a rounded answer of 1,474 meters cubed. That finishes up our examples on volumes. And all of the examples that we're going to be putting up this week, I want you guys to know a couple of things before I put up the assignment. While you're working on this assignment, a couple of helpful hints. In some of these questions, they're going to give you the big B equals. So they're going to give you the area of the base. If you see a big B equals, that's the area of the base. That's that whole chunk of the formula. I know in every one of these examples that we went through, we went in and found the area of the base. Well, in some of these examples, they made it even easier by giving you the area of the base. So keep that in mind. If you see a big B equals, that literally will go straight into your formula. Second helpful hint, when you're doing these, write them out, put them in the correct places, and then see what you're missing. In the last case, we know we're missing the h, so we have to figure out how to get it from the information given. Some of those situations will be in the homework assignment. That's why I went through one like this. So keep that in mind when you're going through. You're going to be using the Pythagorean theorem. You may have a question or two that deal with sine, cosine, and tangent. So keep that in mind when you're looking at the assignment and working through the assignment. Now you're going to see posted below is the assignment for this week. Like always, if you have any questions whatsoever, please, please, please post, reply, email me, let me know what your questions are so that I could answer them. I'm going to be praying over each and every one of you this week, and I hope that you guys have a great week, and I look forward to seeing each and every one of you soon.